Welcome to Cisco HyperFlex video series. This is HyperFlex Topology. When you receive your Cisco HyperFlex servers and the fabric interconnects, you will have to set up the environment for the servers and integrate the new system in your data center. First, you unbox the equipment and insert it into racks. We will take a look at the procedure of physically setting up the HyperFlex topology, racking, and installing the Cisco UCS Manager to gain management access to the system. Cisco fabric interconnects have front-to-back airflow. The air is pulled in on the fan side and exhausted on the side with ports. The Cisco UCS HX servers, on the other hand, have the exhaust on the fan side. This is because the system is meant to be rack-mounted so that the ports are on the same side, making cabling much easier and allowing for shorter and more organized cable runs, while maintaining the hot-cold separation. You will mount the hardware like this. Each HyperFlex server comes equipped with an MLOM VIC card, which provides connectivity to the fabric interconnects. There are also two 10 gigabit ports pre-installed on the motherboard, which are not used, and the management 1G Ethernet port, which will also not be used since the Cisco fabric interconnects provide in-band management through the VIC. The serial console port can still be used to connect to Cisco Integrated Management Controller. The VIC cards also define the compatibility with the upstream fabric interconnect device due to port and speed mismatching. You cannot connect the servers using a breakout cable due to QoS limitations, but you can adapt a 40G SFP to 10G QSFP Plus using a QSA adapter, but not vice versa. Other connectivity is supported aside from VIC 1457 not yet being supported on third-generation fabric interconnects. It is advisable that the top-of-rack switches you use to connect the fabric interconnects to support jumbo frames. This is the default option when installing HyperFlex. Make sure you disable jumbo frames in the HX installer if you will not be using them, or the installer will fail. This is because even though the data communication of the HyperFlex data platform does not normally run through the top-of-rack switches, certain resilience scenarios cause this situation. In our topology, we will be using a full Cisco device stack, and will be using the VIC 1387, which provides two 40 gigabit QSFP Plus ports. We will use the Cisco QSFP Plus Twin-X cables between devices and will connect each server to both fabric interconnects. You must use a consistent cabling scheme on both fabric interconnects or the HyperFlex installation will fail. This is why we will connect the left ports to the top fabric interconnect and all the right ports to the bottom one. We will use matching ports for each server going top to bottom. After we have connected the servers, we connect the fabric interconnects to the upstream switches, each fabric interconnect to each switch. We will use a virtual port channel configuration to achieve maximum throughput, as well as maximum resiliency. We also need to connect the L1, L2 links between the fabric interconnects, so they function in high availability mode. We use normal Ethernet cables here since this link only serves to synchronize information between the two FIs. Now we will plug in all the devices into power outlets. It is now time to create the UCS domain. The fabric interconnects have management ports on the front side, next to the power supplies. One is an IP management port, and the other is a console port that we will be using to perform the initial configuration of the Cisco UCS Manager. This will configure the IP address on the out-of-band management Ethernet port, which we will connect to an access port on the top-of-rack switches. First, we connect to the console port of the first fabric interconnect and choose console configuration. We will create a new configuration and use a simple password for demonstration purposes. We are using 2 fabric interconnects in high availability configuration, so we say yes. This will be the Fabric A device, and we will name the UCS domain. First, we provide the out-of-band management IP of the Fabric A fabric interconnect, the net mask, and the gateway. Finally, we provide the cluster virtual IP address. We will not set up the domain name or connect the UCS domain to the UCS central. We confirm the configuration and plug in the console cable in the second fabric interconnect. Here, we just provide the password for the first FI and the IP address of the Fabric B interconnect. And we are done. We now connect the IP management port on each Fabric interconnect to an access port on top of rack switches, with an appropriate out-of-band management VLAN configuration. This will provide the out-of-band management access to the Fabric interconnects. The servers themselves will be automatically configured by the HX installer, which will be running outside the HX infrastructure, and it will have to have access to the out-of-band management network, as well as the in-band management network to access the vCenter, NTP, DNS, and the ESXi hypervisors. The HyperFlex uses 4 of these switches on the hypervisor, each with 2 interfaces, one for each fabric. The in-band management provides the management access to the CVMs and the ESXi hypervisors on the in-band management VLAN. The vCenter, NTP, DNS, and the HX installer have to be accessible in this VLAN. The storage data VLAN carries the data traffic of the HX data platform and provides the NFS mount to the hypervisors. CVMs and the ESXis have to be reachable in this VLAN. The VM network VLAN enables connectivity for the individual VMs running on the HyperFlex system. This network is set up in an active-active mode, while all the others are configured as active-passive. These 3 networks are configured by the installer on the installation. The final network is vMotion network, which provides a VLAN for VM migration. This network is configured after the initial installation by running the post-install script. We now know the VLANs to use. Now we need to plan the addressing within the VLANs. The IP subnets must of course be configured so that the devices within individual VLANs are reachable. If the vCenter does not yet exist on the network, it has to be deployed, so that it can be accessed by the installer VM and can access ESXi hypervisors in the in-band management network. We have the equipment racked and stacked. We have the VLANs and addressing planned, and we have the UCS domain set up and reachable for management. We are now prepared for the HyperFlex data platform installation. We will use the information we have prepared in the HX installer, which we will deploy outside the HX cluster. This was HyperflexTopology. Thank you for watching.